Okay, today we're going to continue our study of polynomials. We're going to be looking at something called the factor theorem in particular. So, in the last video, we were looking at this particular polynomial here, 2x cubed minus x squared minus 5x minus 2, and we were trying to divide it by terms like x plus 1, x minus 2, and so on. I'm not so interested in that at the moment. What I'm interested in is what does this polynomial look like, and what can we learn from that? So, let's have a quick look at this polynomial. I've sketched it on Desmos. What I want to highlight is I want to highlight the x-intercepts. So let's have a look at these values here. These are the x-intercepts. And we can see if we just read off from the graph that the x-intercepts are -1, -0.5, and +2. Now, when we're talking about polynomials, it's important that we use another name for this. So instead of talking about x-intercepts, now what we're going to do is we're going to refer to these things as the roots of p of x, right? So these are the roots of p of x. They are the x-intercepts. Well, let's go for a formal definition of roots and then see if we can make sense of that. So here's the formal definition. If p of alpha is equal to 0, then alpha is a root of p of x. Okay? If p of alpha is equal to 0, then alpha is a root of p of x. Well, what does that mean? When is the polynomial equal to 0? Well, if we look at this here, when is the polynomial equal to 0? Well, it's always going to be on the x-axis, right? Because this is when the y value is always going to be 0. So this is when the polynomial is 0. So if I was going to take these three values, right, -1, -0.5, and +2, and substitute them into the polynomial, then I should get 0. So let's try that. Let's take this value here, this root -1, and substitute it into the polynomial. Let's see what we get. So p of -1 is equal to 2 times by -1 cubed, which is -1, minus -1 squared, which is +1, minus 5 times by -1, minus 2. Okay, we just expand that. 2 times -1, -2, minus +1, which is -1, minus 5 times -1 is +5, and minus 2. And so minus 2, minus 1, plus 5, minus 2 is 0. All adds up to 0. So what we've shown, therefore, is that if we substitute -1 into the polynomial, we get 0. That means that -1 is a root of the polynomial. Okay? And if you wanted, what you could do is you could go and check that with the other polynomial, with the other roots as well. Substitute in x is equal to -0.5 and x is equal to 2. And what you should find is, again, you get 0. So returning back to the definition, if p of alpha is equal to 0, then that means that alpha is a root of p of x, right? It's the value where the polynomial will be equal to 0. Well, let's move on. So we've looked at roots. Let's go back to what we were thinking about last time. Last time we were taking our polynomial, p of x, that thing there. We were dividing it, let's say, by x minus 2. And when we did that, we found that we got this other polynomial, in this case, the quadratic, 2x squared plus 3x plus 1. Now we can then rewrite this. Let's do that. Let's multiply both sides by x minus 2. So if we multiply both sides by x minus 2, what we should get is this, right? The polynomial p of x here is equal to x minus 2 times by the second polynomial, 2x squared plus 3x plus 1. So we can rewrite this. P of x is equal to these two things multiplied together. Well, that leads us to the next term that we need to think about, and that term is called factors. Right? These two things here, x minus 2 and 2x squared plus 3x plus 1, these are what we call factors of p of x. And the reason we call them factors, it's similar to when we do factors for numbers, right? If I was to ask you the factors of 6, you would tell me 1, 2, 3, and 6. What do we mean by that? Well, we can take a pair of those numbers, right, and multiply them together, and we should get 6. So 1 times by 6 is 6, and 2 times by 3 is 6. In the same way, if I took this thing here and multiplied it by this thing here, I get p of x. So those are called factors of p of x. So let's give that a formal statement as we did before. If we can write p of x as equal to x minus alpha times by q of x, right? So in other words, p of x can be written as x minus alpha times by some other polynomial that we don't know. If that is the case, then this thing here, x minus alpha, is a factor of p of x, right? X minus alpha is a factor of p of x. Let's go and see if we can think about this a little bit more. So here we've got our polynomial. P of x is equal to x minus 2 times by 2x squared plus 3x plus 1. So this is our second polynomial here. We can actually factorize that once more. We can factorize that quadratic. And if we do that, we're going to get this. Right? So here we've got now 3 factors. Okay? X minus 2 is a factor. 2x plus 1 is a factor. And x plus 1 is another factor. Well, this is going to lead us to what's called the factor theorem. So I want you to observe this, right? Remember that we said that the roots of the polynomial earlier were were -1, -1/2, and +2. So let's note that down again. So remember the roots here were -1, -1/2, and +2. And now what do we say were the factors of p of x? What are the factors? Well, we've got x plus 1, 2x plus 1, and x minus 2. And what you should notice is that there is a relationship between the roots and the factors. The relationship is going to be given by this statement here. So just look at the formal statement. We're saying that if x equals alpha is a root of a polynomial, then x minus alpha is a factor. Right? So, for example, if 5 is a root, then x minus 5 will be a factor. If 7 is a root, then x minus 7 is a factor. So if we just go back and we have a quick look here, right? Let's take this one. We've got -1 is a root, so x minus -1 should be a factor. And that's right, isn't it? Because x minus -1 is x plus 1. And we could look at this one here, right? We've got 2 is a root, and so x minus 2 is a factor. And the last one, this one here, may not look like it's right, but if we say that the root is -1/2, then the factor there should be x minus -1/2, so that's x plus 1/2. And if we just rearrange that by factorizing out the half, we factorize out the half, what we should get is 2x plus 1, right? And that is exactly what we get, right? Because 2x plus 1 there, beg your pardon, is the factor of the polynomial. So, big thing. What is the real thing that you need to learn? You need to know what a root is, right? A root is an x-intercept. It's when the value of the polynomial is 0. And you need to know what a factor is, right? There are things that multiply together to give the polynomial, to give p of x. And then what is the relationship between those two? It's that if alpha is a root, then x minus alpha is a factor, and vice versa. If x minus alpha is a factor, then alpha is a root. For those of you who want things in more technical language, we've got this here, but I don't think you should worry too much about it, right? If P of alpha is equal to 0, this is it's a more fancy way of saying that alpha is a root, right? That's what that means. Then P of x is equal to x minus alpha times by q of x. This is another way of saying that x minus alpha is a factor, right? So top statement there is a way of saying that alpha is a root. The bottom statement is a way of saying that alpha is a factor. And this should also make sense, because if you just follow through with this, right, let's say that we're saying that alpha is a root. Well, let's just substitute alpha into this polynomial. We find P of alpha is equal to alpha minus alpha times by q of alpha. And of course, therefore, what's going to happen is that alpha minus alpha is 0. So it doesn't matter what the other polynomial is, because this thing is going to equal 0 anyway, right? So we have definitely got a root. Okay, so if x minus alpha is a factor, we know that alpha is a root, and vice versa. Okay, how can we use this information in a question? Let's try to sort this out. Okay, here we got a question. We want to show that x equals 2 is a root of the polynomial x cubed minus 6x squared plus 11x minus 6, and we want to find the other roots. How might we do that? Well, remember, what is the definition of a root? A root is such a value that if we substitute it into the polynomial, we should get 0. So what we're saying is, if it's true that 2 is a root, then we expect that P of 2 should equal 0. So let's try that out. Let's substitute in. 2 cubed is 8. 2 squared is 4, so minus 6 times by 4, minus 24. 11 times by 2 is 22, minus 6, right? And if you add all of that up, you should get 0. And that therefore means that x equals 2 is a root. Okay, so we've confirmed the first part. The second part then is we want to find the other roots. Well, we can use the factor theorem. Because if we know that x equals 2 is a root, we also know that x minus 2 is a factor. Okay, so we know that x minus 2 is a factor, so that means we can now use that to do some polynomial division. Let's take our polynomial x cubed minus 6x squared plus 11x minus 6. And we're going to do the division like that. X minus 2. Okay. And I'm going to do this fairly quickly, right? X cubed divided by x is x squared. So that's going to give us x cubed minus 2x squared. Subtract off. That's going to give us minus 4x squared plus 11x minus 6. Minus 4x squared divided by x is minus 4x. We get minus 4x squared plus 8x. Subtract off. 3x minus 6. Then 3x divided by x is plus 3. You get 3x minus 6. Subtract off, you get 0. So what have we just shown? We have now shown that P of x can be written as x minus 2 times by the quadratic x squared minus 4x plus 3. And because that is a quadratic there, we can just factorize that into the two other factors. So what is that quadratic going to factorize to give? Well, x minus 1 and x minus 3. Okay, so to summarize, the polynomial has got three factors: x minus 1, x minus 2, and x minus 3. And if these are the factors, then we also know the roots. Because if x minus 1 is a factor, then x equals 1 is a root. If x minus 2 is a factor, then x equals 2 is a root. And if x minus 3 is a factor, then x equals 3 is a root. Right? We've just used the factor theorem again to find those roots from the factors. Okay, so to summarize, what do you really need to know? You need to know what a root is, what a factor is, and how these relate in the factor theorem. So a root is any value of x such that the polynomial will equal 0. So if you want to state that formally, if p of alpha is equal to 0, then alpha is a root, right? So you substitute the value in, if you get 0, it's a root. Factors. If you can write the polynomial as x minus alpha times by some other polynomial, that means that x minus alpha is a factor. And so how do these two then interrelate? Well, we're saying that if alpha is a root of a polynomial, then x minus alpha is a factor, and vice versa. If x minus alpha is a factor, then alpha is a root. Okay, that is the summary, guys, of the factor theorem. That is quite a big thing for you that you have to learn. I hope that was helpful. I will see you again next time.